All right, two more. Second to last one is called decomposition. This is where you are going to break down and decompose, if you will, whatever you start with. Decomposition, think about biology, where you are breaking down something. Animals will be breaking down different bioparticles. Biology, not me. Okay, so let's stick with chemistry. Decomposition, we are breaking down different molecules into simpler, much easier atoms or ions. So, most of these, we are going to take something like, let's go hydrogen peroxide. Let's go H2O. It's a little easier. So H2O is a liquid. So we're going to break this down into its components. This will often happen. If you don't find anything special about the atom or molecule that you're looking at, it's usually just going to break down into its components. It's very basic. So what you get, I'll draw a longer arrow, H2, why a 2? Because it's diatomic. You remember that from a single displacement video a long time ago. It's diatomic. So you have H2, gas, plus oxygen. So decomposition took AB and broke it down into A plus B. This is the opposite of synthesis at the basic level. Obviously, we're going to have different opportunities to do this, but it's just breaking down what we start with into a couple of different things. I'm just going to make one up off the top of my head. Let's just break apart something like, we'll do iron. I don't want to do that one. Let's do iron sulfide. We'll do iron 3 sulfide. So, oops. Iron 3 sulfide. That's a 2. Okay. It's going to break down into its components. So you get iron plus sulfur. And that's it. There's one more rule that I'm going to show you. This is the basics of it. If you see nothing special, if it just undergoes decomposition and it doesn't have an opportunity to go through this next rule, this is all that happens. It just breaks down. Pretty simple. All right, any of your carbonates. If you are a pop drinker, this is going to be especially important. Okay, this is any of your metal carbonates. Any of your metal carbonates. Those will always break down into the metal oxide plus CO2. Think about your pops. Okay, if you are a pop drinker, you'll notice that there are all those carbonates in your pop. You shake it up, you are speeding up the decomposition reaction that is already taking place. You open your pop, you leave it sit there, it became flat. Flat, in chemistry terms, means that it has completed its reaction, it has completed its decomposition from a carbonate to releasing the CO2. So now you are drinking the metal oxide that's left over. No longer are you drinking the carbonate. Okay, carbonated beverage. That's what you call them. So now it's not carbonated, it's just the metal oxide version of it. Let's take a look. Let's do Ca, CO3, calcium carbonate. This is the most common version. Okay, it's ironic, I'm using chalk. So what do I get? Metal oxide, crisscross, calcium and oxygen. And you get CaO plus oxygen. Sorry, CO2. Okay? And that's it. Let's do a couple more. I'm going to grab a bigger piece of chalk. So, let's go sodium carbonate. Carbonate, remember, is CO3. You crisscross sodium, oxygen. You get Na2O plus CO2. Metal carbonate yields the metal oxide plus CO2. Okay? So anytime you have a metal and a carbonate, carbonate is CO3, so metal plus CO3, it will break down and decompose into the metal oxide plus the CO2. This is pop, and this is the reaction that happens when you drink pop. Okay? You're going to see another one when we do our demonstration. It should be quite interesting. Hopefully you enjoy it. But as for now, I bid you farewell.